Hi everyone, it's Miss Costa here, and in this video we're going to go through the predicted paper for paper 1 for the Edexcel Foundation Maths exam. Now, as it's a predicted paper, none of these topics are guaranteed to come up. This is just a best guess, like with any predicted paper, and especially for paper 1, it's the one that you're least likely to be able to predict exactly, but it's going to still be really useful for revision. So for the first question, we've got an ordering decimals question, and whenever we've got a question like this, it's really helpful to actually write all of the numbers down in a list, a vertical list. So we've got 0.3, 0.31, 0.04, 0.215 and 0.4. Now, these questions frequently, sometimes people just look at it and they're like, oh, 0.215 looks like a really big number because it's 215, but they forget to take into account the place value. So the reason we list them is because we can add zeros on the end of each of the numbers to fill them up so that they all have 3 digits after the decimal point, and then we can compare the place values equally. So if we are going to just imagine there is no decimal point and compare the numbers, then we can see the biggest one here would be 400. So that's a cheap way of doing it. You can just put the zeros, make sure that all of the numbers have the same number of decimal places, and then you can compare them that way. Or the correct way is to look at the place value, and it's asking us to start with the smallest number. So what we want to do is look at the first digit after the decimal point, because that's where the place value is the largest. Just in general, in any number, the first column is your 10th column, then you've got your 100th column, and then you've got your 1000th column. So this would represent 3/10 over here. This would represent 6/100ths. And this would represent 9/1000ths. So the further away we get from the decimal point, the smaller the value of the number. So that's why we're looking for the smallest number. So in the first column, we're going to look for what the smallest digit is. And over here, I can see that that would be 0.04. So I can just start listing them down here. So 0.04 is going to be the smallest number. I then start again by looking at the next smallest digit, and that would be 2. So I'm going to write out 0.215. Then what happens is I've got 2 numbers that have the same value. So I've got 3 and 3. So what I do is I look next door, and I'm looking for the smallest one. 0 is less than 1. So that means that 0.3 must be next, and 0.31 would come after. And that leaves me with the final one, which would be 0.4. So either you can fill in all of the digits with zeros, or you can look at the place value. Next, we need to turn a percentage to a fraction. Now, the definition of a percentage is a number that is out of 100 or divided by 100. So 35%, automatically I can just write it as 35 out of 100. So to turn a fraction into a percentage, to turn a percentage into a fraction, any percentage can be written out of 100. So here I've got 35 out of 100. That's a fraction. It doesn't ask me to simplify it. I could, but I don't need to because it doesn't say write it in its simplest form. If I were to simplify it, I would start by dividing by 5. So I know that 35 divided by 5 is 7, and 100 divided by 5 is 20. So you can simplify it, but you're not required to. It's just saying write 35% as a fraction. And to turn any percentage into a fraction, you just write it out of 100. Next, we've got some metric conversions. So for metric conversions, there's a few things that you do just need to know off by heart. So for instance, centimeters and meters. In 1 meter, there are 100 centimeters. So this is a fact that you need to know. And if you know this fact, you can write it out in the exam and then use the conversion accordingly. So to go from meters to centimeters, to get from 1 to 100, I'm timesing by 100. So if I wanted to go from meters to centimeters following the arrow, I would times by 100. And similarly, to get from 100 to 1, I'm dividing by 100. So if I wanted to get from centimeters to meters, I would go in the reverse direction and I'd have to divide by 100. So 425 centimeters into meters, I'm going to have to divide by 100, and that would be 4.25. If you're not confident dividing by 100 in one go, you could just start by 100 is the same as dividing by 10 and then dividing by 10 again. So when you're dividing a whole number by 10, you just move everything one place to the right. So you'd put a decimal point here, and then to divide it by 10 again, it would become 4.25. So you can do it step by step. For the next question, we need to change 3.8 kilograms into grams. So the metric conversion I need to know is that 1 kilogram is equal to 1,000 grams. And again, we can use this to figure out what we need. So to get from kilograms to grams, I'd multiply by 1,000, and to do the reverse, I would divide by 1,000. In this question, I'm asked to turn kilograms into grams. So I'm going from kilograms to grams, which means I'm going to multiply by 1,000. So 3 times 1,000, I know is 3,000. So 3.8 would be 3,800. It's always helpful to just think to yourself, okay, if I ignored the decimal, I multiplied that whole number by 1,000, what would it be? And then think to yourself, okay, so that means it must be 3,800. Okay, next you're told that here is a list of numbers and that you need to write down the number that is both a square number and a cube number. So the square and cube numbers are numbers that you should know off by heart. The square numbers are numbers that are multiplied by themselves twice. So 1 times 1 is 1 squared is 1. Similarly, 2 times 2 can be written as 2 squared, which is 4. So the square numbers are when you multiply a number by itself. And then the cube numbers, and the reason they're called square numbers is because if you created a length, let's say this length was 3 and this length was 3, and you multiplied the lengths, so you had 3 blocks here and 3 blocks here, it would form a square. So any number multiplied by itself is going to form a square, has equal sides. And similarly, the cube numbers are when you multiply a number by itself, so it forms a square, and then you multiply it again, so it forms a cube. So to work out the cube numbers, if you don't know them off by heart, and you can just do it in the exam, so cube numbers would be, for instance, the first one would be 1 cubed, 1 times 1 times 1 is 1. The second one would be 2 times 2 times 2, which is 8, and so forth. So a lot of people don't necessarily know their cube numbers off by heart. As long as you know the method, you can work it out in the exam, but it is really good if you can just memorize at least the first 5. So what I'm going to do is I'm just going to write out the first few to help me. So 5 times 5 is 25, times 5 again is 125. I don't need to go any further because that's the maximum number over here. So I know that 27 is a cube number, 64 is a cube number, and 125 is a cube number. So I've just underlined cube number in green and ticked them. The square numbers, again, I can just write them out quickly. I'm just writing them out fully just to help you if you don't know them, but 3 times 3 would give me 9, 4 times 4 would give me 16, 5 times 5 would give me 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100, 11 times 11 is 121, and 12 times 12 is 144. So out of these, which one is also a square number? So I know 16 is a square number. I know that 81 is a square number. And I also know that 64 is a square number and nothing else is. So I need to write the number that is both a square number and a cube number. So that would be 64. So 64 is a square number because 8 squared makes 64, and it's a cube number because 4 cubed makes 64. So you don't need to do that reasoning, but you could if you wanted to, because you know 8 times 8 is 64 and 4 times 4 times 4 is 64. So yeah, if you don't know the numbers off by heart, just write them out in the exam. Next, we've got a list of 4 fractions. So it tells me that one of these fractions is not equivalent to 2/3, and I need to write down this fraction. Now, there's a quick way you can do this if you're pretty confident with equivalent fractions, but if not, let's just take it bit by bit. So one of them is not equivalent to 2/3, so I want to see if I can simplify which ones I can simplify to 2/3. So you got 6/9, so what can I divide by? What's common to both 6 and 9? I can divide them both by 3. So 6 divided by 3 is 2, 9 divided by 3 is 3. So that actually is equivalent to 2/3. So let's try the next one. 10/15. Well, what can I divide 10 and 15 by? What's the highest common factor? They both divide by 5. So 10 divided by 5 is 2. 15 divided by 5 is 3. So that also works. Then let's have a go at 8/12. What's the highest common factor? That would be 4. But if you didn't identify the highest common factor, you can just start dividing by 2. And then you can divide by 3, 5, basically the prime number. So if you don't identify the highest common factor, that's fine. You just divide by 2 and then you divide by 2 again. So 8 divided by 4 is 2. And 12 divided by 4 is 3. So this one is also equivalent. That must mean that 16/20 is not equivalent to 2/3, but let's just double check. So the highest common factor of this would be 4. So 16 divided by 4 is 4, and 20 divided by 4 is 5. So 16/20 simplifies to 4/5, therefore that is the odd one out. Okay, next we've got simplifying expressions, and there's 2 different things we need to know when we're simplifying. So when we're multiplying expressions, we multiply the numbers together, and then in algebra, let's say we wrote 6p. Whenever a number and a letter are next to each other, that always implies there's this invisible multiplication sign. So if I were to simplify 6p, I would simply write it, if I were to simplify 6 times p, I would simply write it as 6p. So here what I can do is I can say, okay, 6 times 3 is 18. So I'd be left with 18 times t times p. And in algebra, when I'm multiplying letters together, so for instance, p times t, I would write that as pt, because this little invisible algebraic multiplication zoo is implied. So to simplify this, I would just write 18tp. Whenever you're simplifying with multiplication, you never write the multiplication. And then I need to simplify with addition. So this is where I am adding, and what I look for is letters that are the same, well, letter, and also the same power. So all of these are to the power of 1. So I've got e plus e. So I can imagine if I'm adding or subtracting, to help make it easier, that's when you can imagine it's an object, so something tangible. So for instance, e plus e, I could say that's an elephant plus another elephant. That would give me 2 elephants. And f might be, I don't know, a frog. So that would be 2e plus f. So the difference is when I'm multiplying, I'm bringing them all together, multiplying everything together, and I don't write the multiplication signs. And when I'm simplifying, bringing together, collecting like terms, by adding, I collect all of the ones with the same letter, put them together, and the plus sign remains. Next, I have a probability scale. So the key with a probability scale is it always goes from 0 to 1, where 0 is it's impossible for that thing to happen, and 1 represents it's absolutely certain to happen. So for example, it's 100% certain. So over here, I have been given an 8-sided spinner, which means I have 8 choices in total, 8 options on what things could land. So to work out the probability of anything happening on that spinner, it would be out of 8, because the probability is always out of the total. So I have 8 options, and I need to work on the probability scale. I need to mark with an X the probability that the spinner will land on an even number. So I know I have 8 options. Now I want to see how many even numbers I have. So I've got 2, 4, 6, 10, 8 and 14. So that is 6 numbers are even. Now I need to write it on the probability scale. So what I can do is simplify the fraction first. That might make my life easier. So if I divide by 2, that would give me 3/4. So 3/4, if we are not 100% sure, this is something that we should kind of memorize if we don't know it yet. So we've got 0 represents nothing, 1 represents absolutely certain. Halfway would be 0.5, which is equivalent to a half. And we said that the probability of this happening is 6/8, which we simplify to 3/4. So a half, if I used my equivalent fractions, that's the same as 2/4. Now, in between 0 and a half is going to be 25%, or 0.25, or the equivalent is 1/4. And over here, it's going to be 0.75, or the equivalent is going to be 3/4. So these basic conversions you need to know. And this basically is the first 25%, or the first quarter. This is the second quarter, and it adds to make a half. Then we've got the third quarter and the fourth and final quarter. So I need to mark 3/4 on the probability scale. So that's going to be halfway between a half and 1, and it doesn't need to be exact. It's the intention that they're going to mark, and I just mark an X there. Then says on the probability scale, mark with an X the probability that the spinner will land on a 7. Well, there are no 7s on that spinner, so that's impossible. So I'd mark it as 0, because there's 0 out of 8 numbers are 7. Okay, next I've got a pictogram. So I'm told that the incomplete pictogram shows information about the number of ice creams Lily sold in her shop on Monday, Tuesday and Wednesday. So I'm given some information. I'm told that on Monday she sold 21 ice creams. And this is important because I can use that information to figure out what the pictogram means. So I've got a big square that's split into 4 parts. And then I've got 3/4 of a square. Or I could look at it as 1, 2, 3, 4, 5, 6, 7 small squares. So 7 small squares is equal to 21 ice creams. So what I could do then is divide by 7 to figure out what one small square must be. So 7, well, divided by 7 is 1, and 21 divided by 7 is 3. So that tells me that one little square is worth 3 ice creams. Therefore, a big square that's made up of 4 little squares is going to be 3 times 4, which is 12. And what I want to do is make that very clear in my key. So I would draw the full square, which is, you're always drawing whatever they've given you. So in this case, they've given you squares. So I'd say that is equal to 12. Then it says on Tuesday, Lily sold 33 ice creams. So what I'm going to do is draw squares to fill that up. So that's going to be 4. So 4 times 3 is 12. So that's 12. 2 squares is going to be 24. And then if I added on another full square, that would be 36. So I need to think carefully. 1 square would be another 3. So 27 plus 3 would be 30, plus another 3 would be 30. Now, sometimes they are very nice and they allow you to split it up in, so for example, instead of drawing 3/4 of the shape, they might let you draw it like that, but it's best if you can just draw 3/4 of the original shape. So next, we've done the 33 ice creams, and for Wednesday, Lily sold 18 ice creams. So just to help you, and we could have done this earlier actually, we know that 1 little square is going to be 3 ice creams. Therefore, half of the square is going to be 6, and 3/4 is going to be 9. And obviously a full one would be 12. So I draw my first square, and that's 12. And I know to get to 18, I need another 6. So that's going to be half a square. So that gets me 18, and that has me finishing the pictogram and the key. The key is very important because that tells you how much each picture is worth. So next it says, write the number of ice creams sold on Monday to the number of, that's supposed to say ice creams sold on Wednesday as a fraction in its simplest form. So on Monday, they sold 21, and on Wednesday, they sold 18. So what I would do is I'd say the number of ice creams on Monday were 21, on Wednesday it was 18, so that would be 21 over 18. And I need to simplify that. So I can divide by 3, 21 divided by 3 is 7, 18 divided by 3 is 6. So that's 7/6, and in its simplest form, 7/6, or as a mixed number, that would be 1 and 1/6. To turn a fraction into a mixed number, you say to yourself, how many times does 6 fit into 7? Once, and then there's 1 left over. Okay, next we've got a direct proportion problem. So Summer buys 3 kilograms of apples, and we know that 5 kilograms of apples costs £7.50. So the best thing here to do would be to do the unitary method. So I equate 5 kilograms with £7.50. And then what I can do is figure out how much 1 kilogram must be. So how do I get from 5 to 1? I need to divide by 5. And £7.50 divided by 5, I'm then going to need to do on the other side. So I can use the bus stop method. So 5s into 7 go once, remainder 2. So I'd write a little 2 over here. 5s into 25 go 5, and then 5s into 0 are 0. So 1 kilogram costs £1.50. And then I know that Sama buys 3 kilograms, so I'm then going to times that by 3. And I'm going to do £1.50 times 3. So you might be able to do that in your head. If not, probably the best way here, because we're dealing with money, would just be to do repeated addition. So we've got 0 plus 0 plus 0 is 0. 5 plus 5 is 10, plus 5 is 15. So I carry the 1. 1 plus 1 plus 1 plus 1 is 4. So that would be £4.50 that Sama pays. Okay, next we've got solving equations. So if this is something that you struggle with, I would recommend using the function machines to help you. So the way you do that is you start with the letter, the variable, and you think, what's the first thing that's happening to it? Well, there's 3f, so that must mean it's being multiplied by 3. Then what happens? You subtract 8 from it, and what comes out is 13. So to figure out what f is, we work backwards and we do the inverse function. So like we're undoing everything that's happening to it. So the inverse of taking away 8 is adding 8. And the inverse of timesing by 3 is dividing by 3. So we're going to do 13. It tells me that the first step I take is I add 8 to both sides. So 13 plus 8 is 21. And then the next step it tells me to do is to divide by 3. So I'm going to divide both sides by 3. and that would mean that F is 7. The reason I'm doing the inverse is because it cancels out. Hopefully you can see -8 plus 8 is 0. So that cancels out here. And then 3 divided by 3 is 1. That's why I'm left with 1F. That's why I do the inverse. And whatever I do to one side, I have to do to the other. So this equation is a little bit trickier. And whenever you're doing a function machine, you can use it for anything, even really, really tricky equations, but you need to only have the variable on one side. So the variable is the letter. So in this case, the variable is P, and I've got P on both sides. So what I want to do is find the smallest variable and subtract it, move it to the other side. So here I've got 3P, here I've got 1P. Remember that anything on its own, there's one lot of it. Like we don't say I have one apple, I just say I have an apple, an object. We don't need to specify that there's one. So there's an invisible 1 in front of any letter. So what I want to do is subtract 1P so that I can move it to the other side. To move anything from one side to the other, you always have to do the inverse function. So 3P, take away 1P. And remember when we said when we're simplifying, collecting like terms with additional subtraction, we can imagine it's a tangible object. So let's say 3 potatoes, take away 1 potato, leaves me with 2 potatoes. So 2P is equal to 23. And then again, we can use a function machine if we're not sure what we need to do. So we start with P, and 2P means it's being times by 2. And what comes out is 23. So I work backwards. That means I'm going to have to divide by 2 because that's the inverse of multiplying by 2. So divide both sides by 2. So P is going to be 23 divided by 2. Now, don't be afraid. Sometimes people look at this, especially in the non-calculator paper, and they're like, oh, I must have done something wrong because that's not a whole number. Sometimes they are going to have decimals, and you can just leave numbers as fractions, especially if your answer is something like 6/7. You don't have to worry. You can leave it as a fraction. You will get the marks because you get the marks for having the correct answer in any of its equivalent forms. But dividing by 2 isn't too hard. So this one we can do. So you can use the bus stop method if you're still not sure. So 2's into 2 go once, and 2's into 3 go once. We've run out of numbers, so we put a decimal point and we fill it up with some zeros. So 2's into 3 go once, and there's a remainder of 1, and 2's into 10 go 5. So 23 divided by 2. Okay, so in this question, I'm told that Yanis uses his lorry to deliver furniture. And I've been given a conversion graph, and a conversion graph is where you have one thing being compared to another thing. In this case, it's cost and distance. So as we can see, the larger the distance, the larger the cost. And it says you can use this graph to find the delivery cost for different distances. Now, for each delivery, there is a call out fee plus a charge for the distance. And we are being asked how much is the call out fee. So this might be terminology you might not have come across before. Essentially, if you've ever taken a taxi, sometimes you might notice that when it arrives, it's already charged you. So it might have already charged you £2.50. That's called like a call out fee or a fixed charge. Before you even do anything, there's a fixed price. So the call out fee, or the fixed charge, how it might be called, is the starting point, the starting price for any of it. So over here, we can see that 30 is the starting price. So even if you don't travel any distance, you're going to get charged £30. So the call out fee must be £30. Essentially, the call out fee or the fixed charge is going to be where the line crosses the y-axis. That's the start point. Then I'm told that Yanis makes 2 deliveries of furniture on Sunday. His first delivery is 40 miles away. His second delivery is 130 miles away, and this is supposed to be in miles. So what were the total delivery costs on Sunday? So the total is generally when we add multiple things together. So first we're going to need to work out what the delivery cost was for his first delivery. So 40 miles away. And the way we do this is we go to 40 miles and we draw a straight line up to the graph, and then we go across to read it. So my line's very thick, but between each 10, like between 40 and 50, there are 5 little squares. So that must mean that 5 squares represent £10. Therefore, 1 square is going to represent, if I divide by 5, 10 divided by 5 is 2. So 1 square represents £2. So it's also very important that you use your scale, your axes, and figure out how much each little square is worth. So in this case, it is 2 squares up. It's a very small graph on my, yeah. So that would be £42. So delivery 1 is 40, he got charged £42. And for the second delivery, that's 130 miles away. So again, I know that 120 is here, 140 is here, and 130 is going to be exactly halfway. So this would be 130. So I draw a straight line up to the graph and I go across, and once again, and that's 3 squares up. So 72, 4, 6. So that would be £76. So what was the total delivery costs? Well, I'm going to add 42 plus 76. 2 plus 6 is 8. And 7 plus 4 is 11. So the total delivery costs were £118. Next, I've got a cost problem. And these kinds of questions actually trip up a lot of people because you might never have seen a meter reading before. So you need to know how that kind of works. So every house has like a little meter where you can read your electricity, and it basically starts from 0 and then it keeps building up and up and up. So the units keep increasing, and you can figure out how much you've used by subtracting the end from the beginning of the month. So for example, with a really simple example, let's say it's when you first installed the meter. At the end of the month you had 120, so in that month you would have used 120. But in the next month, let's say you used 200, the end of it would be 320 because you add however much you've used. So the number keeps on increasing and increasing and increasing. That's why at the end of August, the bill is more, and at the end of April, it's less. So I'm told that at the end of April, Tilly's electricity bill reads 56,456, and at the end of August, it's 58,127. Tilly pays her electric bill quarterly. That's another bit of terminology you might not know. So generally, we've got the year, and in business and just sometimes talking about the seasons, it's split into 4. So quarterly means every 4 months because there are 12 months in a year, and we split it into 4. So this question is actually wrong because it should be every 3 months. So let's just, for the purpose of this question, let's say that that is May. So anyway, 12 split into 4 is 3. So every 3 months you pay the bills. So Tilly pays her electricity bill quarterly, and you need to work out how much she had to pay for the electricity she used over the last quarter. So that means essentially what was the difference between the 2 meter readings. So we've got 58,127, and we've got 56,456, and I want to work out the difference. So to work out the difference, I just subtract. So 7 take away 6 is 1, 2 take away 5 I can't do, so I have to borrow. So 12 take away 5 is 7, 0 take away 4 I can't do again, so 10 take away 4 is 6, 7 take 6 is 1, and 5 take away 5 is 0. So in total, for this quarter, she used 1,671 units. And then I'm told that she is charged 27p for each kilowatt per hour of electricity she uses. You don't need to know the terminology, you just need to pick up the key information. So essentially, she's used 1,671 units and she gets charged 27p for each unit she uses. So I'm going to need to do 1,671 times by 27. Now, there's lots of ways that you can do it. The way that I prefer is using the Napier's bones. There's loads of different things it's called, but essentially I've got 4 digits here, so I'm going to do 1, 2, 3, 4 boxes and 2 digits here, so I'm just going to write that up here, 1671 times by 27. Then what I do is I just split each of these boxes into 2 with a diagonal. And then I only ever have to multiply single digits. So in the top of the box, I write the tens, and in the bottom, I write the units. So for example, 1 times 2 is 2. So that's 0 tens and 2 units. 1 times 7 is 7. So that's going to be 0, 7. 7 times 2 is 14. So I'm going to write 1, 4. I'm basically just splitting the number up into 2. 7 times 7 is 49. 6 times 2 is 12, 6 times 7 is 42, 1 times 2 is 2, and 1 times 7 is 7. So the reason this method is nicer is because you're only ever multiplying single digits, and then you just add everything. So what we do is we go one diagonal row, one at a time. So below this diagonal, I've just got 7. Then I look in the next diagonal. 9 plus 2 gives me 11. So I write 1 here and I carry 1 into the next diagonal. 4 plus 4 is 8, plus 2 is 10, plus that 1 is 11. So again, I carry that into the next column. And maybe it might help if I just wrote it in a different colour, just so it doesn't get confusing. Then 1 plus 2 is 3. 3 plus 7 is 10, plus 4 is 14, plus 1 is 15. So I carry the 1 into the next one. And the next diagonal, I do 2 plus 1 plus 1, which is 4. And then the last column is 0, so I don't write anything. So that gives me 45,117. So she had to pay 45,117 pence. It hasn't actually asked you for units, but if the question had asked you for how much she paid in pounds, you just divide it by 100, because £1 is 100 pence. So to divide by 100, I'd move everything one place value to the right. So I put the decimal point in over here. So divide by 10 and then divide by 10 again. That would be £451.17. But you don't have to do that. I'm just showing you what you can do if it had asked you to convert it into pounds. Okay, next we've got a substitution question. So whenever you've got like this strange looking algebra with an equal sign in it and lots of variables, and you're told the value of some of them. So for instance, you've got x and y in the equation and you're told the value of x is 6 and the value of y is -3, you can substitute them into the equation. So it might help to actually think to yourself, what is the algebra doing? Remember, a number and a letter next to each other means they're being multiplied. So 3x means 3 times x, and 4y means 4 times y. So what I can do is substitute the value that I've been given. So I'm told that x is 6, so I'm going to do 3 times 6, and I'm told that y is -3, so I'm going to put -3 over there, and then I work it out. 3 times 6 is 18, 4 times -3 is -12, and what's really important is you've got 2 signs here. You've got a positive and a negative. Whenever you've got a positive and a negative next to each other, they always rewrite to make a negative, because adding a negative is the same as subtracting. So if the signs next to each other are the same, you're adding. If they're different, you're subtracting. So in this case, I would rewrite this as 18 minus 12. So therefore, L equals 6. Next, I need to expand, and expand, that just means multiply out. So you're always going to see it with brackets involved. So what is helpful is you start with the term on the outside, in this case 5x. You draw a little arrow to the next term inside the bracket. So you're doing 5x times by x. So what does 5x mean? It means 5 times x, and you're timesing that by x again. So when you're multiplying something by itself, just like we did with square numbers, we know 3 times 3 is 3 squared. X times x is going to become x squared. So that would become 5x squared. And then we do 5x times by minus 2. So again, we could split that up if we wanted to. So 5 times minus 2 is minus 10. So that would become minus 10x. Next, we've got an equation with a bracket. So whenever you see brackets, generally it's really helpful to just expand them. So we've got 4m. So 4 times m would give you 4m. And then 4 times by 3 is 12. And that equals 31. So again, you can use the function machine to help you decide what needs to go first. So m goes in. It's being multiplied by 4. Then I add 12 and 32 comes out. That tells me that to do the reverse, the first thing I'm going to have to do is subtract 12. And obviously you don't actually need to write this out in the equation. You can just use it in the function machine, but it's good to use the function machine to help you then get used to doing it this way. So 31 take away 12 is going to be 19. And then what do I have to do? The next bit would be I'd have to divide by 4. So remember last time we said don't worry about it needing to be a whole number. So m is 19 over 4. You could work out the value, but you could also leave it as a fraction. If we worked out the value, we've got, well, 4's into 1 don't go. 4's into 19. So you know you've got 4, 8, 12, 16, 20. So that's 1, 2, 3, 4. Lots of 4 go into them. And then you're left with a remainder of 3. 4's into 30. So you've got 24, 28. 4 times 7 is 30. And then you know you've got a remainder of 2. And that would be 5. So you could work that out, but you're not obligated to. Okay, next we've got a frequency tree. And a frequency tree is just a way of displaying data to just help us get a little bit more organized. So I'm told that 250 people attended a school play. Each person was asked if they wanted a program or not. 120 of the people were female. 82 didn't want a program, and 150 people in total wanted a program. So let's start with the information that we have. We know there are 250 people in total. I'm then told that 120 of the people were female. So female is along this line. So I'd write 120 here. And the key thing with frequency trees is that each little branch thing or column must add up to what it came from. So these two branches branch off from here. So therefore 120 and this must add up to 250. So if we did 250 take away 120, 0 take 0 is 0, 5 take 2 is 3, 2 take 1 is 1. So that means there must be 130 men. So next we fill in what other bits of information we have. It says 82 of the males didn't want a program. So males are here, and I know that 82 of them had no program. I know that these two branches must add up to 130, so I can do 130, take away 82. 0 take 2 I can't do, so I carry. 10 take away 2 is 8. 2 take away 8 I can't do. 13 take away 8 is 5. So that would mean this is 58. and I'm told 150 people wanted a program. So if 150 people wanted a program, that means that this and this must add up to make 150. So again, I'd do 150 take away 58. So 0 take 8 I can't do. 10 take away 8 is 2. 4 take away 5 I can't do, so I borrow. 14 take away 5 is 9, so that would be 92 over here. And I know that these two branches need to add up to 120. So what I'd do is 120 take away 92. 0 take 2 I can't do, so carry the 1, that would be 8. Again, I can't, so I carry. Ooh, Siri scared me there. Oops. Okay, hold on. Now I've forgotten 11 take away 9 is 2. So that would be 28. And to double check that they're all correct, everything in this column should add up to 250. For part B, I'm told that one of the 250 people who attended won a prize. Write down the probability that this person was a female that didn't want a program. So a female that didn't want the program, I go along with female, no program, that's 28 people. So 28 out of the total 250 people, that would be the probability. The way you do probability is the denominator is always the total, and then the numerator is your chosen thing. So in this case, female, no program. Okay, next we've got a stem and leaf diagram. So I'm told that Alahan wrote down all the heights of the boys in his class, and the heights are shown below. I then need to draw a stem and leaf diagram to show this information. So the way a stem and leaf diagram works is you split it up like this, and then you ideally want your leaf part to only be 1 digit, which makes it easier to compare. So at the moment, these numbers are 3 digits. So what that means is if I had a key, let's just choose the first one, for example. If I only want 1 digit in to be the leaf, I'm going to have to split it up so that the branch has 2 digits. So 15 goes here and the 4 goes here, and in total that number represents 154. So if I'm writing a key, I would say 15 with the separation of 4 represents 154. Doing a key means you understand what each number means, because it might be that 15 represents 15,000, or you're doing something crazy. So what we want to do is think to ourselves, what's the smallest and the largest value, just because then that will tell us how many rows I need. So I think 154 might be the smallest, and the largest is 194 maybe. So that would be 15, 16, 17, 18, 19. I would need 5 rows. So 1, 2, 3, 4, 5. Most of the time you will be provided with a stem and leaf diagram, but I just thought let's make it a little bit trickier just so that you can do one totally from scratch. So another thing that is very good is to do a rough stem and leaf diagram, and then do your final ordered stem and leaf diagram. So I'm going to do the ordered one over here at the end. The rough one is just so that I can eliminate all the numbers. So I start with writing the stem. So 15, 16, 17, 18, 19. So that would represent 150 something, 160 something. So the first one, 154, I'd write a 4 there. Next one, 162, I'd write a 2 there. 164, I'd write there. 155, I'd write a 5 there. 164, I'd write there. 174 is over here. 184 is over here. 194, 188, 172, 163, 154, 167, 176, 171, 163, 175, and 180. So I've drawn a rough stem and leaf diagram. Now what I can do is put it in order, because when you have a stem and leaf diagram, the whole point is that you want it ordered so you can easily compare the data. So I've got 4, 5, 4. So I'm going to write 4, 4, 5. And then I've got 2 3s, 2 4s, and a 7. Then I've got 1, 2, 4, 5, 6, 0, 4, 8, and 4. And the amount of times people get this wrong, literally because they try and rush straight into the ordered one and they just make one little mistake and they lose marks, is actually quite astounding. So I really recommend doing the rough draft first. Also double check. So how many numbers were there in total? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So that means you need 18 things in your stem and leaf diagram. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So you know you've got it right. If you haven't, then do it again and see what you might have missed out. So that is my stem and leaf diagram. Then I'm told that Allahan says that the modal height, modal is just the plural for mode, which means the most common. So he says the modal height is 4 because 4 occurs most often in the diagram. Well, that's correct. There's a 4 here, 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 and here, which is definitely the most frequently occurring single digit. However, that forgets about the fact that this is a stem and leaf diagram. So these aren't just representing 4s. Was that also a 4? Yeah. These aren't just representing 4s. This represents 154. This represents 154. This represents 164. So I would say no, he is incorrect. The modal height, so the modal height is the most common value, so it's really helpful to actually identify it. So in this case we've got 154 appearing twice and also 174 appearing twice. Anything else? We've also got 163 appearing twice. So if you have more than 2 things appearing at the same frequency, then there is no mode. So actually we can't find a modal height. We just say there is no mode. Another reason might be he has forgot about the stems. The 4 does not represent 4, but 154, 164, etc. Obviously, also, I don't think many people are 4 centimeters tall. Okay, next I need to work out the median height. Now, to work out the median, you put all your numbers in order, and then you find the middle number. So on a stem and leaf diagram, the way we can work out the median is we've already ordered them and we just cross them out from the smallest to the largest. So we'd go 1, 2, 1, 2, 1, 2, 1, 2. And people always get a little bit confused here because like you're going forwards and backwards. So if that does really confuse you, it might be worth just writing out the numbers or just be really careful. So cross it, cross, 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 and then what happens is we're left with 2 middle numbers. So we've got 167 and 171. To work out the median, if you've got 2 numbers, what you do is also, I forgot to mention, you should label your key, as in make sure that you draw the key for the stem and leaf diagram, otherwise you won't get the final marks. So we've got 167 and 171. When you've got 2 values as the median, you want to find the way between those two values. So the safest way to do it is add them together and divide by 2. So 167 plus 171, 7 plus 1 is 8, 6 plus 7 is 13, and that would be 338. So that would give me, and I've run out of space, so 338 divided by 2. 2's into 3 go once, remainder 1. 2's into 13 go 6, remainder 1. And 2's into 18 go 9. And you might have also been able to just figure it out because you're like, okay, halfway between 167 and 171, I know there's a difference of 4. Half of that is 2. So if you could, that's great. If not, the fail-safe is add the two values together, divide them by 2. So the median height is 169 centimeters. Okay, so in this question, it's a rate of pay question, and all that means is that you've got two different amounts you're being paid depending on whether you're working within your contracted hours or overtime. So most people, if they have a job that allows them to work overtime, you have, let's say, 30 hours that you have in your contract that you work, and you get paid your normal amount for that. And if you choose to work extra hours, so in the evenings or at the weekends, for example, then you get paid overtime because that's considered as like unsociable hours, or you're working more than your allocated amount, and therefore you get rewarded for that. So your normal pay is a set amount, and then your overtime is normally a multiplier of that. So, 1.5 times or 2 times the amount. So that's what rate of pay essentially is. It means how much you get paid per hour, and you get paid different amounts depending on whether it's your normal hours or your overtime. So I'm told that Perry works in a factory and that her normal rate of pay is £15 per hour. When Perry works at the weekends, she is paid overtime for each hour that she works. Her rate of overtime pay is 1.5 times her normal rate of pay per hour. So first of all, we can just write a few things down. So I know that her normal rate of pay is £15 per hour. Then what I can do is I've been given information about her overtime. So her overtime pay is going to be 15 times by 1.5. So I can work that out. Now, this is a non-calculator paper, and I'm doing 15 times by 1.5 because it says her rate of overtime pay is 1.5 times her normal rate of pay. So that means whatever the normal pay is, you multiply that by 1.5. Now, if you're good at multiplying decimals, then you can just do that. But if you're not, then probably the best thing to do on a non-calculator paper is to turn the decimal into a fraction. So 1.5 as a fraction would be 1.5, and as an improper fraction would be 3/2. So 0.5 is a half, 1.5, turn it into an improper fraction, you multiply 1 by 2, that becomes 2, and then you add the numerator, so that's 3/2. But we'll go into fractions more in another question. So I've got 15 times by 3/2, and the reason I turn it into a fraction is because multiplying by fractions for some people is a lot easier. All you do to multiply fractions is you multiply the numerators by each other and the denominators by each other. Now 15 obviously is on its own, it doesn't have a denominator, and to turn any number into a fraction you just write it as over 1. So that would become 15/1 times by 3/2. I do 15 times 3, which is 45, and then 1 times 2, which is 2. So 15 times by 1.5 is 45 divided by 2. I can then use the bus stop method to figure out what that must be. 2's into 4 go twice, 2's into 5 go twice, but then I run out of numbers, so I put a decimal point and a few zeros. So 2's into 5 went twice, remainder 1, and then 2's into 10 go 5. So 15 times by 1.5 is 22.5. So I know that would be £22.50, so her overtime pay is £22.50. Now, the next piece of the information I'm given is that last week Perry earned £670.50 in total. So she worked 3 hours on Saturday and 4 hours on Sunday, And I know that that is going to be overtime because I'm told that when she works at the weekends, she is paid overtime for each hour she works. So that means she did 7 hours of overtime. Now, what I can do is work out how much she would have been paid for those. So I know that 1 hour of overtime is worth £22.50. So 7 hours is going to be 7 times £22.50. Now there's a few ways that you can do this again. I would probably, because it's a non-calculator paper, split it up and just make life easier for myself. So 7 times £22.50. I would split it up into £22 and 50 pence. So I do 7 times by 22 and then 7 times by 50. So I'm just splitting it up into the pounds part and the pence part. So 7 times 22, 22 times 7, 7 times 2 is 14, 7 times 2 is 14, add the 1, so that's 154. And that's in pounds. And then 7 times 50, 7 times 5 is 35, and then you add the 0, so that's 350 pence. And I know that in £1 there's 100 pence, so to turn pence back into pounds, I divide by 100, so that would be £3.50. So for her overtime work, she got paid £154 plus £3.50. So if I add them together, I've got 0 plus 0 is 0, 5, 7, 5. So for her 7 hours of work, she got paid £157.50. So the question's asking me to work out the total amount of hours Perry worked last week. Well, I know that she worked 7 hours of overtime, and I know that that would mean she got paid £157.50 for those overtime hours. And I know that in total she earned £607.50. So if I did £607.50, take away £157.50, that would give me the difference, the remaining amount, and what's remaining must be how much she got paid for her normal hours worked. So 0 take 0 is 0, 5 take 5 is 0, 7 take 7 is 0, 0 take 5 you can't do, so we're going to borrow, so that will become 5, 10 take 5 is 5, 5 take 1 is 4. So that means for her normal pay, she got paid £450. So let's just make this a little bit simpler. I know that for her overtime, 1 hour of overtime is £22.50. For normal pay, 1 hour is £15. And I know that she worked however many hours that produced £450. So what I can do is I can go backwards and do 450 divided by 15 to figure out how many hours she must have worked, because if for each hour that she works she gets paid £15, I do 450 divided by 15, that tells me how many hours she worked. And if you know how to do long division, then great, just keep going with that. If not, the best thing to do is to turn the division into a fraction, because 450 divided by 15, this sign here on the fraction, it means divide. So whenever you're doing divisions, you can always write them as fractions and simplify. So I know that 0 and 5 are always going to be multiples of 5, anything that ends in 0 and 5. So I can start by dividing by 5. If it's not immediately obvious to me what it would be, I can use the bus stop method to just help me out. So 450 divided by 5, 5s into 4 goes 0, remainder 4, 5s into 45 go 9, and 5s into 0 go 0. So that would be 90, and 15 divided by 5 is 3. Then if it's not immediately obvious to me again, I can just use the bus stop method. So 3s into 9 go 3, so that would be 30, and 3 divided by 3 is 1. So I simplified it by first dividing by 5, then dividing by 3, and I worked out that that must be 30 hours, because 450 divided by 15 is 30. So let's bring it all together. So I know that she worked 30 hours of normal pay and 7 hours of overtime. So that must mean that the total amount of hours Perry worked was 37 hours. Okay, next we've got a cost question involving fractions and percentages. So I'm told that Krupa bakes 400 cakes for a charity cake sale. Her aim is to raise £300 for charity. And on Monday, Krupa manages to sell 3/10 of the cakes she bakes. So she sells these for £1 each. Okay, so on Monday, she sells 3/10 of the cakes she bakes. She bakes 400 cakes. So I'm going to need to work out 3/10 of 400. Now, there's lots of ways that you can do this again. Probably the best way is to just draw yourself a bar model. So this is obviously, I'm taking it back a step just in case you're not super confident on these. So 3/10, what does that actually mean? It means something has been split into 10 equal parts. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 3 of those are what you're after. So 400 in this case has been split into 10 parts. So if I do 400 divided by 10, that would be 40. And to divide by 10, if it's a multiple of 10, then you just chop off the 0. So each tenth, I know that 1/10 is 40, and 3 of those tenths is going to be 40 times 3, which is 120. So that's the best way to do fractions. Of course, the shortcut, once you understand this visual representation, is you divide by the denominator and then times by the numerator. So 400 divided by 10 is 40, times by 3 is 120, but it's always best to understand it conceptually first. So I know that she sold on Monday 120 cakes at £1 each, means she made £120 on Monday. Then I'm told on Tuesday she manages to sell 40% of the remaining cakes. So that's important. It's not 40% of the whole amount of the cakes, it's 40% of how many are remaining. So if she sold 120 on Monday, I'm going to have to subtract to find out how many are remaining. So 400, take away 120, 0 take 0 is 0, 0 take 2 you can't do. So that becomes 10, take away 2 is 8, and 2. So there are 280 cakes left. And she manages to sell 40% of these. So let's just put our key information. Monday, I know she made £120. Tuesday, I'm going to work that out now. So I know she has 280 cakes and I want to work out 40%. So this is a non-calculator paper. So I'll show you the best non-calculator way for working out percentages. So 40% of 280. What I would do is I would start by working out 10%. And the trick for working out 10% is super easy. It is just divide by 10. Okay, so to work out 10%, all you do is divide by 10. So 10% is going to be 28. And if I know what 10% is, I know that 40% is 4 times larger than that. So I can, if I know 10%, I could work out 20, 30, 40, 50, 60. If I know 10%, I can then halve it for 5%. So 10% is a great starting point. So I know 10% is 28. What I'd have to do is multiply both sides by 4 to get 40%. So I can do 28 times by 4. So 4 times 8 is 32. 4 times 2 is 8, plus 3 is 11, so that would be 112. So that means she managed to sell 112 cakes. So Monday she sold 120 cakes. Here she sold 112 cakes. And I'm told that she sells them at a reduced price of 80p, probably because it's the last day of the charity sale. She's just trying to sell as many as possible. So I'm going to have to do 112 times by 80. So a good way to do this on the non-calculator, I could either do 112 times by 80 like this, or what I could do is think to myself, okay, how can I actually make up 80 using multiplication? I can split it up into 8 times by 10. So I could do my multiplication in 2 parts. I do 112. So instead of saying 112 times by 80, what I'm saying is 112 times by 8 times by 10, because 8 times by 10 is the same as 80. So I can just split it up, because timesing by 10, all I do is I add a 0. So I just multiply by 1 digit first, and then I can just multiply by 10. So 112 times by 8, I've got 8 times 2 is 16, 8 times 1 is 8, add the 1 is 9, 8 times 1 again is 8. So 112 times by 8 is 896, and then I'm left with times by 10, so that's going to be 8,960 pence. So once again, my answer is in pence. I'm going to want to turn it into pounds. I know that £1 is 100 pence. So what I want to do is divide by 100. So 8,960 divided by 100. I can do it bit by bit. So dividing by 10 would give me 896. Dividing by 10 again would be 89.6. And that written as pounds would be £89.60. So I have the total amount that she managed to raise. And I know that she wanted to raise £300. So Monday, she raised 120. Tuesday, she raised £89.60. And be very careful with money to make sure you're lining everything up with the decimal points, the pound signs and everything. So let's add it all up. So 0 plus 6 is 6, 0 plus 9 is 9, 2 plus 8 is 10, carry the 1, and then you're left with her total. Did Krupa manage to raise enough money? So this is a question, so you're going to have to answer it. And you would say no. She only managed to raise £209.60, which is less than 300. So sadly, she didn't meet her fundraising target. Okay, so this question is a linear sequences kind of question where I need to find the nth term. And the nth term of a sequence is essentially the rule that allows you to find any term in the sequence. So every sequence has its first term, its second term, its third term, its fourth term. And if you know the nth term, you could find the 20th, the 70th, so forth. So the way we find the nth term is what we do is we look at our sequence, and then it's a linear sequence. We know that if it's going up or down by the same number each time. So first we look to see if there's a constant difference. So to get from 4 to 9, I add 5. To get from 9 to 14, I add 5. 14 to 19, I add 5. And 19 to 24, I add 5. So I can see it's going up in 5 each time, which means it's going up in the 5 times tables. So whatever times tables it's going up in, I write that number and then an n. So if it was going up in 3s, I would write 3n. If it was going up in 7s, I would write 7n. And the reason for this is because n represents for the first, like what term it is. So for instance, for the first term in the 3 times tables, I do 3 times 1, which is 3. Similarly, for the first term in the 7 times tables, I do 7 times 1, which is 7. That's where the n part comes from. So you work out what it's going up in. That's the times tables it's going up in. So you write that number and then an n after it. So now we know it's going up in the 5 times tables, we can say to ourselves, okay, so this is going up in the 5 times tables, but if it actually was the 5 times tables, I can write the 5 times tables above it. And then I think to myself, it's the 5 times tables, but it's shifted. It's the 5 times tables, but each time from the original 5 times tables, how do I get from 5 to 4? I take 1. How do I get from 10 to 1? I take 1. How do I get from 15 to 14? I take 1. So what you do is you write the times tables above your sequence, and then you find the difference from the original times table to the sequence. So to get from 5 to 4, I'm subtracting 1. So I'm going to write -1. And that's it. That's all I need to do to find the nth term of a sequence. So just a quick recap. You find the difference, whatever the difference is, that's the times tables it's going up in. Then you write the times tables above it, and you see whether it's been shifted upwards or downwards. So that's my nth term. And then I'm being told I need to find the 20th term of the sequence. So if you remember, I said that n represents which term it is. So if it's the first term, n would be 1. If it's the 4th term, n would be 4. Here, I want to find the 20th term. So I'm going to say n is 20. And then this is the rule of the sequence. So what I do is I put n equals 20 into this rule. So 5n take away 1 means 5 times by n, because remember, whenever a number and a letter are next to each other in algebra, it means they're being multiplied. So 5n, I've said n is 20, so I'm going to do 5 times 20, take 1. So 5 times 20 is 100, 100 take 1 is 99. So the 20th term of the sequence is going to be 99. And then it asks me to clarify whether something is a term in the sequence. Now there's 2 ways to answer this question. The short way would be to notice that in this sequence, every number ends in either a 4 or a 9. So you could say no, as each term ends in 4 or 9, never 7. But sometimes you're going to have questions where it's not so easy to spot that, and to double check it, to prove it, what you would do is you'd make your rule, so the rule of the sequence is 5n minus 1, you'd make that equal to what they want to know if it's a term. So you'd say 5n take away 1 equals 37. You'd then solve this equation, so use your function machine if you need to. That would tell us that the first thing we do is we need to add 1. So 5n is 38. And then what I would need to do is divide by 5. So therefore n is going to be 38 divided by 5. Now 38 divided by 5, I could quickly just do a bus stop, but I know it's not going to be a whole number because 8 is not in the 5 times tables. So 5's into 3 don't go. 5's into 38 goes 7. Remainder 3. 5's into 30 goes 6. So n is 7.6, which means 37 would be the 7.6th term, and terms can only be integers. Like, you don't say who came 7.6th in the race, you just have first, second, third, fourth, fifth, sixth, seventh. So basically, to check if something is a term in a sequence, you make the rule equal to the number you're checking, you solve it, and if n is a whole number, so an integer, like 5, 7, 9, that tells you it's the 5th term, 7th term, 9th term, then it is in the sequence. If n is a decimal, like 6.3, 7.9, it's not in the sequence. And that's how we do that question. Okay, next we've got set notation. So it's really important to know these 2 little signs and what they mean. So this sign essentially is the intersection. So a way of remembering it is it kind of looks like an A, so it could be like A and B. So what is in the intersection of A and B, which essentially means if you had a Venn diagram, what is in A and in B? It has to be in both of them. So the intersection means what is in both. And then you have this, which means the union, which means what is in A or in B or in both. So essentially, if you had a Venn diagram, it would be what's in A or the middle bit or in B. So all of this. So that's just the key information. So you might want to annotate it when you get in the exam, just to remind you. So say to yourself A or B or both, and this would be A and B. So what's in the intersection? So let's start by writing out what the possibilities of being an A would be. So it tells me it's the multiples of 3 between 2 and 22. So the first multiple would be 3, 6, 9, and multiples just means the numbers times tables. So 3, 6, 9, 12, 15, 18, and then 21. And then here it's the odd numbers between 5 and 25. So it's between 5 and 25, not including them. So that would be 7, 9, 11, 13, 15, 17, 19, 21, 23. So now what I need to do is list the members of A and B. So what is in both A and also in B. So let's see anything in common. So we've got 9 in common. We've got 15 in common. And we've got 21 in common. So that would be what I'd do for the first question. And then for B, I want to list what is in A or in B or in both. So essentially I want to write down everything. So I'm going to write 3, and you don't have to do it in order unless it specifies it. So you could start just by writing this. So 3, 6, 9, 12, 15, 18, 21, and you know you've already written 9, 15 and 21, so you can cross it out from there, and you're left with 7, 11, 13, 17, 19, 23. You don't repeat yourself because you've already written that numbers. So that's all we need to do if we're listing things. The key thing is the terminology. This is like the intersection. So if you visualize it and you've done Venn diagrams, it's just the bit that intersects. So literally the things that appear in A and B, the things that there's 2 of, if that makes sense. And then A or B or both means anything in A, anything in B, plus anything that is in both of them. Okay, next we've got an inequality. So I'm told here is an inequality, and I'm being asked to solve it. So this one's slightly trickier because it's it's an inequality with variables on both sides. So what this means is whatever you'd normally do. So for instance, if you had 3x is less than or equal to 12, you would divide by 3 to get x on its own. So that still applies. It's just instead of just doing it for one side, you have to do it on both sides. So you're dividing each part by 3. So to get x on its own, 3 times x. To do the inverse, you divide by 3. So minus 6 divided by 3 would leave you with minus 2. You keep the signs exactly as they are. You'd be left with x, and then less than or equal to 12 divided by 3 is 4. So that's all we need to do for solving. Whatever's in the middle, like for instance, just a really quick example, if it said 3x plus 2 is less than 12 and then less than minus 6, the first thing we'd have to do is take 2 from both sides, just like we would if it was just this part here, and then we divide by 3. But if you need more help on that, just let me know and I can go into more detail. So that is this inequality solved. Then I need to list all the integers. Remember that integer means a whole number, so no decimals. So list all the integers that satisfy this inequality. So what this means is -2 is less than x, which is less than or equal to 4. Sometimes it might help to actually write it out in words. So this sign, basically the little inequality, you can imagine it's a little crocodile, and the crocodile is always facing the biggest number because crocodiles are hungry and obviously will reach for the biggest thing. So the crocodile teeth are facing the x, which means x is bigger than -2. So I know that x has to be greater than -2. It doesn't have, if it has this sign underneath it, it means it could be equal to as well. It's not. So I know that -2, which is over here, it has to be greater than. So greater than is in this direction. So the next integer, the next whole number after -2 on a number line would be -1. Then you've got 0. Then you've got 1, 2, 3. Until we get to 4, we know that x is less than or equal to 4, which means it can actually be 4 because it's less than or equal to it. So we'd write 4 as well. And then I need to represent this inequality on the number line below. So this is pretty simple. All you do is you draw a dot above wherever it says. So it says -2. We draw a dot there, and 4. I know that x has to be in between these two values. I draw a line between them, and then I consider carefully. If it's greater than or less than, I leave the dot blank. If it's greater than or equal to or less than or equal to, I colour the dot in. So that's the only differentiation. You draw your dots, join them together. If it can be equal to it, then you colour the dot in because it symbolises that x could be -1, 0, 1, 2, 3 or 4. So it's just an easy way of seeing where the x values must lie between. And that's all inequalities are. We don't know the exact value of x, we just know that it has to be greater than something or less than something. Okay, so here we've got a ratio question, and we've got two different ratios that we're somehow going to try and combine. So I'm told that in an aquarium, the number of goldfish and the number of angelfish are in the ratio 6:5. So it always helps to just actually write out what is happening. So I know that goldfish to angelfish are in the ratio 6:5. And then I'm told that the number of angelfish and the number of guppyfish are in the ratio 10:7. So what you might notice is that angelfish appear in the first ratio and the second ratio. So angelfish are the thing that's in common. So I could write angelfish, the ratio is 10:7, angelfish to guppy. So I've got three different things that I somehow want to combine so I can compare them. So the thing that is in common is the angelfish. And what I want to do is make it so that they are equivalent ratios. So if I think about it, the ratio is 6:5. How can I get it so that it's equivalent? The angelfish are equivalent to 10. Well, what have I done to 5 to make it 10? I multiplied by 2. So I'm going to need to do the same over here. So 6 times 2 is 12. So then I know there are 12 to 10. I've made that ratio equivalent, if that makes sense. So this 6:5 is the same as 12 to 10. It's just I've made it into an equivalent ratio so that then I can compare this with this. So 12 to 10 to 7. So I've changed 6:5. I'm trying to combine 6:5 and 10 to 7. I know that this is the thing that they have in common. So I've changed this to 12 to 10 as they are equivalent ratios. Therefore, this is now equal. So I can write it all as one big ratio, 12 to 10 to 7. So now that I've done that, I have a point of comparison. I know that 12 parts are goldfish, 10 parts are angelfish, and 7 parts are guppyfish. Now I'm told that there are 12 guppyfish in the aquarium. That should say 14. Minor error. There are 14 guppyfish in the aquarium. How many goldfish are there? So 7 parts is equal to 14 fish. So if I think about it, I've got 1, 2, 3, 4, 5, 6, 7, and that is equal to 14 fish. So if I did 14 divided by 7, that means that each little part is worth 2. So for example here, if there's 10 parts, I'd do 10 times 2, which is 20, so there'd be 20 angelfish. And here I'd do 12 times 2, because each part is worth 2. So that would be 24. So there are 24 goldfish. This is a slightly trickier ratio question. The key is to try and line them up, make one of them, make them equivalent ratios, so then you can compare them all. And then just do your parts work. So, you know, 7 parts is equivalent to 14 fish. Therefore, 1 part must be worth 2. And so multiply each of the parts by that. So yeah, there are 24 goldfish. Next, I am being asked to draw a straight line graph. I haven't been given the grid, and this is, well, this can happen. So if you have been given a blank grid and you haven't been given a table of values, then just draw your own. You have been told that you want to draw the graph of y is 4 minus 2x. So the equation is y is 4 minus 2x, and 2x just means 2 times x. So I might write that out just to help me out. And then I need to do this for values of x from -2 to 3. So I write my x, I write my y, and I'm going to start from -2 to 3. So -2 minus 1, 0, 1, 2, 3. And now what I need to do is work out the y coordinates. So the way I do that is by using this equation. So I know that y equals 4, take away 2 times x. And it's always best, easiest, most helpful to start on the right hand side. So over here, when x is 3, I'm going to do 4 take away 2 times 3, which is 6. So y is going to be -2. Then I'm going to do it for when x is 2. So 4 take away 2 times 2 becomes 4 take away 4, which is 0. Then I'm going to do it for 1. So 4 take away 2 times 1 becomes 4 take away 2, which is 2. Then I do it for 0. So y equals 4 take away 2 times 0. 0 times anything is 0. So that would just remain as 4. Now, hopefully you notice that the coordinates are going up in a pattern. So if you do this way and you start on the right, you can make your life easier by realizing, oh, each time is going up in 2s. So you can actually predict what the next one would be. That would be 6, that would be 8. But you want to always double check your work. So to double check if you've predicted it correctly, try it for the last coordinate. So 4 take away 2 times -2. Y would be 4 take away, and then 2 times -2 is -4. So you'd end up with 4 take away -4. And when we've got 2 signs next to each other and they are the same, so either 2 positives next to each other or 2 negatives, they become a positive. So that becomes 4 plus 4. So y would be 8. So you know you're correct. Now that you know that your table of values is correct, what you can do is start plotting your graph. So the reason we've split the table up into x and y is because you're trying to work out the x and the y coordinate. So over here, if we took 1 as an example, this coordinate, the x coordinate is 3, the y coordinate is -2. So that would be 3, -2. So I go along well, that's annoying because the graph doesn't go to 3, but never mind. So we're going to ignore that one. But if it did go to 3, we'd go 3, -2 over here. Anyway, next, 2, 0 would be over here. So this coordinate would be 2, 0. This one would be 1, 2, and so on. So 1, 2, 0, 4, minus 1, 6, and minus 2, 8. So you've got all of your points drawn, and then you need to join them together. The amount of people that miss this out is unbelievable, but you need to join them together to form a straight line. And that's what you do. If you, for example, if your line looks like this, you know that this coordinate you would have calculated wrong. So if you're drawing a linear graph, and that means if it doesn't have an x squared in it, if it has an x squared in it, that's a quadratic. If it's just a graph like y equals 3x plus 7, that's linear. And that means it needs to be a straight line. So if it's not a straight line, you've done it wrong. If it's quadratic, it's going to look like this. And if it's a cubic graph, it will look something like that. But yeah, that's how we do this. Next, we've got some fraction arithmetic. So the key thing here is to know how to convert our fractions, mixed numbers, into improper fractions. So a really quick example, we've got 2 and 2/3. Now, what does that actually mean? It means 2 wholes, like 2 whole amounts, and then 2/3. So what I'm splitting things in is thirds because the denominator is 3. So here I've got like 2 wholes have been filled up. So you've got 3/3 makes 1. You've got 3/3 here, that makes 1. And you've got 2/3. So in total, you've got 3 plus 3 plus 2, which makes 8. So 2 and 2/3 would become 8/3. Now, you can draw them out and split them out into whatever your denominator is, or there's a quick way to turn fractions into mixed numbers into improper fractions. What you do is you multiply the big number by the denominator, so 2 times 3, and then you add the numerator. So 2 times 3 is 6, add 2 is 8, and your denominator is always going to remain as what it originally was. So 2 and 2/3 is 8/3, and then 1 1/4. Let's do the same thing, and let's use the shortcut way. So 1 1/4, 1 times 4 is 4, plus the 1 is 5, so that would be 5/4. So the key thing here is that when you're adding and subtracting, so when adding and subtracting fractions, they need to have the same denominator. So what I'm going to have to do is I've turned them into improper fractions first. Now I need to give them the same denominator. So to do that, I look for their lowest common multiple, the first number that appears in their times tables. If you're not super confident with finding the lowest common multiple, then just write out their times tables. So you've got 3, 6, 9, 12, 15, 18. You've got 4, 8, 12, 16, 20. And look for the first number that appears in both. So the lowest common multiple of 3 and 4 is 12. Then you think to yourself, okay, what did I multiply 4 by to get to 12? I times it by 3. So I'm going to have to do the same to the 5. Whatever you do to the denominator, you have to do to the numerator to keep them as equivalent fractions. So 5 times 3 is 15. And then what did you do to 3? What did you multiply 3 by to get it to 12? You times by 4. So you do the same to the numerator. You've got 32. So now that they both have the same denominator, you can just subtract. So 32, take 15, you've got 12 take away 5 is 7, so that would give you 17/12. Now they haven't asked you to simplify your fraction or write it as a mixed number, but if they did, what you would do is then think to yourself, okay, to turn it back into a mixed number, how many times does 12 go into 17? Well, I know the 12 times tables is 12, 24, 36. So I know that one lot of 12 fits into it, remainder 5. So I'd write it as 1 5/12. So that's for adding and subtracting. The key is that they need the same denominator. And if you're not good at this, then really practice converting between mixed numbers and improper fractions, and it'll make your life so much easier. Next, we've got dividing with fractions. And again, you want to turn it into improper fractions. So 1 times 3 is 3, plus 2 is 5. So that would become 5/3 divided by 2 times 7 is 14, plus 3 is 17. So that would be 17/7. Now, the trick for dividing fractions is keep, change, flip. It's normally called the KFC method, but I actually prefer KCF because then it's in order. So keep the first fraction as it is, change the division sign to a multiplication sign, and then for the last part, flip the fraction. So that would be 7/17. And to multiply fractions, all we do is we multiply the numerators together and the denominators together. So 5 times 7 is 35, 3 times 17, 3 times 7 is 21, 3 times 1 is 1, add the 2 is 3. Have I done something wrong? 3 times 7 is 21. Oh, yes. 3 times 1 is 3, add the 2 is 5. It's been a long day. Let's just rewrite that. So that would be 51. So 35/51. And I don't think you can simplify that. You could try dividing by 3, but it wouldn't. So yeah, that's the simplest it can go. Okay, so in this question, I have been given information about the weekly earnings of 30 people who work in a theme park. And I need to work out an estimate for the mean weekly earnings. So this is essentially working out the mean from a grouped frequency table, and group frequency means that instead of just having one number here, there's a class interval. So the earning, for example, for this one would be anywhere between 150 and 250 pounds. So when I have a grouped frequency table, the first thing I want to do is create an extra column where I can just write down the midpoint. And that's the first step that should come to your mind. So the midpoint is halfway value between the intervals. So between 150 and 250, halfway is 200. Between 250 and 350, halfway is 300. Between 350 and 450, halfway is 400, 500 and 600. So once you've got your midpoint, because with a normal frequency table, like let's say we've got 6 dogs and there's 7 of them, all you'd do is you'd multiply. So that would be 42. But because it's a grouped frequency table, the most accurate thing is to find the midpoint. So that's why we do that. So your next column would be the midpoint times by the frequency. Frequency just means the amount. So essentially what you're doing is you're trying to work out an estimate for the weekly earnings. So we know that 10 people earn between 150 and 250 pounds. So we're estimating that the majority of them earn about 200. It's the fairest way to do it, find the midpoint. So we do 10 times 200, which is 2,000, because if one person earned 200 pounds, that's 200 pounds. If 2 people, we do 2 times 200, which would be 400, but we've got 10 people here, so we do 10 times 200, which would be 2,000. For the next part, we've got 8 times 300, so 8 times 3 is 24, and then I add on the 2 zeros. Then we can do 7 times 4, 100, so 7 times 4 is 28, and then add on the 2 zeros. 3 times 5 is 15, and then add on the 2 zeros. And 2 times 6 is 12, add on the 2 zeros. So when I've done this and I've completed my table, what I want to do is work out the total amount of money. So your final column is going to give you the total amount of the thing that you are. If it's talking about height, it would be the total heights. So we get a total of here. And we also want a total of the frequency. Now, normally you're actually told this, so we know that there's 30 people who work in the theme park. So we don't need to work that out. But what I want to do is work out the total earnings. So I've got 2,000 plus 2,400 plus 2,800, and I might just do this bit by bit. So let's just do this addition first, so it doesn't get too confused. So that's 0, 4 plus 8 is 12, 6 plus 1 is 7. So that's 7,200. So then I know that all of this is 7,200. So I can do 7,200 plus 1,500 plus 1,200. And that would give me 5, 6, 7, 8, 9, 7, 8, 9. So that would give me a total of 9,900. So that means in total, everybody in the theme park earns, as an estimate, £9,900, and there are 30 people. So how do we work out the mean? We have the total values divided by the total frequency. So what we do is we do the last column, the total of the last column, divided by the total frequency. That's kind of how you can remember it, but as long as you remember what the last column is, the last column is working out what the total amount earned is. In this case, it's always going to be the midpoint times by the frequency if it's a grouped frequency table. So the total of the last column is 9,900. The total frequency is 30. So I can divide by 10 to simplify my fraction, which is 990 divided by 3. And then I can use the bus stop method. So 3's into 3 go 3, 3's into 9 go 3, 3's into 9 go 3, and 3's into 0 are 0. So an estimate for the weekly earnings is £330. Okay, next I've got a polygon question. So I'm told that the size of each interior angle of regular polygon, and regular is a key thing here, to the size of each exterior angle is in the ratio 2 to 3. So interior to exterior is 2 to 3. And I need to work out how many sides the polygon has. So the first thing is that it's a regular polygon. Regular means the polygon has all sides are equal and all angles are equal. So that makes my life a lot easier. The second thing I need to know is that in any polygon, so let's say you've got a hexagon here, this is what we call the interior angle. And then if you continue the shape, so there's a straight line here, if I continued that line, this would be the exterior angle. So essentially, the piece of information you need to know is that the interior and the exterior angle, they meet on a straight line, so therefore interior plus exterior angle of a polygon must sum to 180 degrees because they're on a straight line. So I know that the interior to the exterior is in the ratio 2 to 3. I know that the interior to the exterior angle, they must add to 180. So the interior is 2 parts, the exterior is 3 parts. And I'm going to split 180, therefore it's being split, I can imagine, this straight line is split into 1, 2, 3, 4, 5 parts, because there's 1, 2, 3, 4, 5, or I could have just done 2 plus 3. So 180 is split into 5 equal parts. So 180 divided by 5, 5's into 1 don't go, 5's into 18 go 3, remainder 3, 5's into 30 is 6. So each little part is 36 degrees. The interior angle is going to be 2 parts, so 36 times by 2 is going to be 72 degrees, and 36 times by 3, so 72 plus 36 is going to give me 108. So I've worked out what the interior and the exterior angles are, and now I need to work out how many sides the polygon has. So another thing that I know, there's quite a lot of knowledge that you need to know about for this question. So in polygons, if you shrunk this shape further and further and further and further, eventually it would become a dot. And what do I know about angles at a point? I know that they sum to 360 degrees. So essentially, all of the exterior angles of a polygon, if you shrink it down and down and down, it would shrink down to a dot. So all exterior angles sum to 360 degrees. So what I can do is then think to myself, okay, if all of the exterior angles sum to 360 degrees, how many? So found another little error. It's supposed to be the other way round. It's supposed to be 3 to 2. Therefore, we switch this around. So the interior angles are 108 degrees and the exterior angles are 72 degrees. So I then know that in my polygon, the exterior angle is 72 degrees. And I need to figure out how many lots of 72 fit into 360. So 360 divided by 72. I can either count up in 72s or I can just simplify the fractions. So I might start by dividing by 2. So 180, 360 divided by 2 is 180, and then that's 36. Divide by 2 again, that would be 90, and 36 divided by 2 is 18. If you can't do it in your head, then just use the bus stop method. Then I can divide by 2, that would be 45 divided by 9, and 45 divided by 9 is 5. So work out how many sides the polygon has. It has 5 sides. Sorry about the muck up. Yes, it was just the wrong way around. Okay, next we've got a quadratic graph. So the diagram below shows the graph of a quadratic. A quadratic means it's got an x squared in the equation, and all quadratic graphs form this shape because any negative multiplied by itself is a positive, so it's always a mirror reflection. So first thing is, it asks me to write down the turning point of the quadratic. Now the turning point of a quadratic is as simple as it sounds. It's literally the point at which the graph turns. So it's either going to be this point here, or if the graph is like this, it's going to be that point there. So what we want to do is identify the turning point, which is over here. So the coordinates of that would be, this would be 0.5 minus 6, the x coordinate along the corridor, y coordinate down the stairs. Next, I need to write down the coordinates of the y-intercept. Now this is the same as with your straight lines. The y-intercept is literally where the line crosses the x-axis. So this is quite small on my iPad, but it's going up. There's 1, 2, 3, 4, 5 squares. So there's 5 squares and there's a difference of 2. So 2 divided by 5, you could imagine it's 20. 20 divided by 5 is 4. So 2 divided by 5 is going to be 0.4. So each little square is 0.4. So minus 6 take away 0.4 would be minus 5.6. So the coordinates would be 0 minus 5.6. So the y-intercept, the x-coordinate is always going to be 0. And the y-coordinate is literally going to be the point where it touches the graph. So that's the y-intercept. Over here is the turning point. And the last piece of terminology you need to know for quadratics is what, how you find the solutions, or another word is the roots. And that is where the graph crosses the x-axis. So here and here. So the roots are where it crosses the x-axis. And let's have a look over here. So it's, this would be 2.5. And there's 5 squares again, so each little square is 1. So that would be 1, 2, 3. So this is 2.3, and this over here is minus 1.123 minus 1.3. So the roots, you can write them as coordinates. So the coordinate would be minus 1.30 and 2.30. You could have also just said x is minus 1.3 and 2.3, but basically the roots are where the graph crosses the x-axis. So if you know that, it's pretty simple to pick up these marks for quadratic graphs, which a lot of people just tend to skip. Next, we've got quite a tricky combination question. So I'm told the diagram shows a prism placed on a horizontal floor. The cross section of the prism, and cross section is the bit that, like, if it was a cake and you chopped it up, each slice would look the same. So the cross section is the part where if you pushed it through the whole shape, it would remain constant. So the cross section is that little bit over there. I'm told that it's a right angled triangle. If it's a right angled triangle, it means that I can use Pythagoras or trigonometry if I need to, with an area of 15 centimeters squared. So that's probably going to come in important. So I know that this triangle has an area of 15 centimeters squared. The height of the triangle is 10. The prism has a length of 20, which we're shown here. And the pressure on the floor due to the prism is 240 newtons centimeter cubed. I need to work out the force. So a formula that you might be given is pressure equals force divided by area, which you could then rearrange. So you want to work out the force. So to work out the force, we'd rearrange that to be pressure times by area. So what that means is I need to work out the area of this, because that is the face that is exerting the pressure. Like if I put that on the table, that's what's coming into contact with the table. So to work out the area would be very simple if I had this length here, but I don't, so I'm going to need to work that out. So I've got this triangle and I know its area is 15 centimeters squared. I know that the formula for the area of a triangle is base times height divided by 2. So I can substitute what I know. I know the area is 15. I know the base, well I don't, but I know the height is 10. And I know that you divide that by 2. So I can rearrange that. If I times both sides by 2, 30 must equal the base times 10. If I divide by 10, then 3 must equal the base. So because it's one of the last questions, it's going to bring a lot of skills together. So changing the subject is what's going to really help you here. So I've worked out that the base is 3. So now that I know that the base is 3, I can work out the area of the part that is exerting the force. So 3 times 20 gives me an area of 60 centimeters squared, and that should be squared. So that's the area. And to work out the force, all I do is pressure times area. They've told me the pressure is (240 newtons. So what I'd do is 240 times by 60. And there's quite a few ways I could do this. The easiest way would just be 24 times 6. So 6 times 4 is 24, 6 times 2 is 12, add on the 2 is 14. So that would be 144. And then I add on the 2 zeros. So that would be 14,400 newtons. Okay, so in this question, we're being asked to make something the subject of a formula. So when we have a question like this, all it's asking us to do is to rearrange it, move things around, so that in this case, A is the subject, which means we want to get it in the form A equals. So there's a few ways we can do this. Once again, we can look at our function machine if we want to. So we could say, what's happening to A? Well, A is first of all being multiplied by 7, and then 12 is being subtracted from it, and B is the subject. So to undo that, what I need to do is add 12 to B and then divide it by 7, and that would make A the subject. So I'd have B plus 12 divided by 7 gives me A. The other way I could do it is if I am just doing the inverse, like when I'm solving equations, is I know I want to move everything from one side to the other to make A the subject. So like the function machine told me, the first thing I do is add 12 to both sides of the equation. So I'd be left with B plus 12 equals 7A, and then I would have to divide by 7. So I'd get B plus 12 divided by 7 equals A. Next, we've got some indices. So what's really important is that you know the law of brackets. So the law of brackets is when you've got indices that are in brackets, let's say it was x squared to the power of 3, what you do is you multiply the powers. And the reason for this is because what does this mean? Well, x cubed to the power of 3 actually means this. So repeated addition is the same as multiplication. And that's why when you've got indices in brackets, you just multiply the powers. So that would become x to the power of 2 times 3. Similarly here, it's just a little bit more difficult because we've got negative indices. So x to the power of minus 3 to the power of minus 4 is going to become x to the power of minus 3 times minus 4, and negative 3 times by negative 4 is 12, because a negative times by a negative always gives you a positive. So that would just be x to the power of 12. Next, we've got a percentage loss question. So Omar buys a smartwatch for £400 and he sells the watch for £160. So technology generally depreciates in value, it goes down in value. So to work out a percentage profit or a percentage loss, what we have to do is work out the difference in values. So to work out the difference, you do the original value, take away the new value, because the difference is, to work out the difference we subtract, divide that by the original value and multiply it by 100. So we're working out the difference in values, divide it by the original value, so the original price, and you multiply it by 100. So what would we do here? The difference in values, the original price is 400. So I do 400, take away the new value, which is 160, divide that by 400 and times it by 100. So 400 take away 160. That would give me 0 take 0, you can't do. 0 take 4, that would become 3. So 10 take away 6 is 4. So that would be 240. So you'd get 240 over 400 times by 100. Now, because this is a non-calculator paper, again, the best thing to do when we've got something like this is to just simplify it. So 240 over 400, if I divide by 10, that would become 24 over 40. I could then divide that by 2. So that would become 12 over 20. Divide by 2 again, that would become 6 over 10. Divide by 2 again, that would become 3/5. So that makes it a lot easier for me to work with. So 240 divided by 400 ends up being 3/5. And then either I could convert 3/5 into a decimal, so 0.6, or I could just multiply the fractions. So 3 times 100 is 300, and then I'm left with 300 divided by 5. If I need to, I can use the bus stop method. So 300 divided by 5, 5s into 3 don't go, 5s into 30 is 6, so that would be 60. So his percentage loss is a 60% loss. And for the final question, we've got an error interval. So it tells me that the distance between London and New York is 5,600 kilometers, measured to the nearest 100 kilometers. And I need to write down the error interval for the distance between London and New York. So an error interval is basically telling me the distance has been rounded, so therefore tell me what it could have possibly been. So the maximum thing it possibly could have been and the minimum thing that it possibly could have been tells me the limits that it is. So what I want to do is I'll write 5,600, and it's told me that it's been rounded to the nearest 100 kilometers. So I'm going to write the 100 kilometers that are on either side of it. And in order for it to have rounded down to 5,500, it would need to be something that is below halfway. So halfway between 5,500 and 5,600 is 5,550. And halfway here is 5,650. So essentially, if you do this and you just work out the distance that you're told, you can bring these values down here to create your interval. So I know that x, I'm going to just call it x, the distance, it needs to be greater than 5,550 and less than 5,650. I know that if it actually was 5,650, it would round up to 5,700. So I'm going to have to say it's less than 5,650. And I know that if it was 5,550, it would still round up to 5,600. So I'd say 5,550, 5,550 is less than or equal to. So it's less than or equal to because it still could be this value. It would still round to 5,600, but it's only less than 5,650 because it can be anything up to that point. So every error interval, you generally write the lower limit or the lower bound is less than or equal to x or p or whatever the value is, which is less than or equal to the, just less than the upper bound. And that's how we do error intervals. So that's the end of this paper. Hopefully it was helpful. If there are any topics that you want me to go into in more detail, then let me know. But happy revising and well done for watching.